Hello and welcome to Practice Problems for Chapter 6, where we're going to be talking about normal distribution. So once again, I'll be going through this video in the assumption that you have already tried these problems and you are just maybe looking for clarification or trying to make sure you have the best understanding possible moving forward for these problems. So this packet is kind of set up in a way to kind of slowly walk you through standard deviation with a normal distribution. So our first problem here, we have a set of data with a mean of 45 and a standard deviation 8.3. We're going to find each value from the given distance from the mean. So if you're going up one standard deviation from the mean, you would just take 45 and then you're going to add 8.3 and that would give you 53.3. When you're going up 3 standard deviations from the mean, the 45 plus the standard deviation times 3, and that will give you 69.9. You can also just add 45 plus 8.3 plus 8.3 plus 8.3 and get the same answer. When we're doing one standard deviation, negative one standard deviation, or one standard deviation down, we will be doing 45. You can do minus 8.3, and that give you 36.7. You can also do part D is 45 plus 8.3 times negative 2 standard deviations down, which will give you 28.4. For the next part here, it's just showing you how to sketch, and I don't normally sketch very often, but if you find sketching to help you, always do it. Always do things that you feel comfortable with and that you understand material best. So I'll do number 2 here just to go through it with you. So we have just a normal bell-shaped curve here, and you have a mu value of 100, and then when you go your standard deviations up, plus 1, plus 2, plus 3, we're just adding 15 each time. So now this is 115, 130, and 145. And then if we go down, minus 2, minus 3, and we go down, it's 85, 70, and 55. Make sure you know that's 70. And so it's just showing you how these kind of look on a normal distribution curve here. I did number 3, and you can check your answers with the answers online for those. I'm going to move down to number 6 because 4 and 5 are doing the same thing, just plugging those numbers in on the normal distribution. We don't need to use video time for that. But what I did was I have number 6 set up here, which is you have a normal distribution with a mean of 5.1 and a standard deviation of 0.9. Find the percentiles of data within each interval, and then you can sketch the normal curve for distribution. So what I have here is I have the curve already done where you have your standard deviations plus and minus and the values at each standard deviation. So number 7 is we want to find the percentile between 6 and 6.9. So what we're trying to do is we're trying to find the values between here, or this whole shape. I'm not going to try to mock up the whole screen. So you're trying to find this area between 6 and 9. So there's a couple ways you can do this. I'm going to show you the way that you should be done, and then we can move from there. So for number 7, we're going to just number this real quick. So for number 7, what you're going to do is you're going to take your x, which is 6, minus your mean, 5.1, divided by the standard deviation of 9, and this is going to give you a z-value, and your z-value will be 1, which is what this is. From the mean to number 6 is 1 standard deviation, and that is what our z-value is always going to tell us, how many standard deviations away from the mean you are. And if you take 1, and then we go to our table on the back, you'll find that the cumulative area to the left, so everything from over here and to our one value, so everything from this point and to the left, which is what the book gives us that cumulative probability, it'll be 0.8413. 3. And that is how much area is underneath the curve. Now, that is for 1. And then the next value we are given is 6.9. So we're going to take 6.9 minus the mean, 5.1 divided by 0.9. Remember, that gives us our z value. And that's going to give us a value of 2, which is, from the mean to 6.9, is 2 standard deviations away from the mean. Once again, we go to the table on the back. That looks like a z. Let's make 2. We find the cumulative probability from 2, and we find that that's 0.9772. So we know the cumulative probability from 1 and the cumulative probability from 2 all the way, remember, in the back of the book there. When we subtract these values, we're only left with what's in the middle here, which is the value from 6 to 6.9, which is what we are looking for from the problem. So we take 0.9772 minus 0.8413. And if we took 8.143 to 9 from 0.977, we get a negative value, and we can't have a negative value here. When we do this, you get 0.1359, or 13.59%. And that is the percent or area between 6 and 9 here. And this is the way you should be doing it. However, you can look online, and what we do know is from our 68, 95, and 99.7 rule that the total area between 1 and -1 is going to be 68%. From 2 to -2 will be 95%, and from 3 will be 97. Well, if you know from -1 to 1 is 68, if you divide that in half, there's 34 on each side. And if you were to actually keep breaking this down, you'll see that this is 13.5%, which is what we got over here. So if you know these rules, you can kind of get a good estimator of what the area should be between. And you can always look these kind of tables up on the internet. Moving on to number 8. So I'll label this one right here, number 8. Doing the same thing. So we're going from 4.2 to 6. Well, we've just kind of looked at that. We know our answer should be about 68%, right? If we use our rules that we know. If we do it the way we just did in number 7, you get 4.2 minus 5.1 divided by 0.9. You're going to get a value of -1, which makes sense because we're landing right on the -1. And then if we go to the table in the back, we're going to find that that has an area of 0.1587. Do the next part, 6 minus 5.1 divided by 0.9 equals 1. Well, we already did 1 up top, so we know that's 0.8413. Remember, if you do it once and you know you did it right, don't waste time keep going back and looking. Use the information that's already been given to you. And we subtract these values out from each other. We're going to get 0.6826. If you use your rules, 68%, we're right there doing that. Now we're going to be looking at number 9, which is what is less than 5.1. So with this one, we're just kind of look. If we look less than 5.1, so we want everything there to the left. Well, if we know it's right on the mean itself right there, we know it's going to be 50%. If you want to see it worked out, I'll do it right here for you. I'll label it number 9. So you take 5.1 minus 5.1 divided by 0.9, you get a value of 0. If you look 0 up in the table in the back, you get 0.5000, and that is the value from there, less than, so it's 50%. Going to number 10. Number 10 is asking us to find between 4.2 and 5.1, so it's between -1 and 0 standard deviations away from the mean, which, if we know that from 1 to +1 is 68, and we're taking half of that, we know our value should be around 34%. If we do number 10, written out here, we take 4, I don't like the way that looks looks a little confusing, we'll go below it. 4.2 minus 5.1 divided by 0.9 equals a value of negative 1. Value of negative 1, remember we did that in problem 8. 0.1587, and oh, sorry about that. And we go to 5.1, we know 5.1 is going to be 5, or 50%, so we're going to take 50, or 0.50 minus 0.1587, and you're going to get 0.3413, or about 34%, which is what we kind of estimated it to be. I'm not very good at writing today, apparently, but we estimated it to be before we started. And last but not least here, we're going to do number 11. So number 11 is greater than 6.9, so remember we're looking at 6.9 and greater than. So remember, everything in the book is telling us from that value and to the left. So when we find 6.9 and to the left, we know we have to subtract it from 1, because the total probability under the whole distribution is going to sum to 1, but the value from our table only gives us from that value and to the left, and we want to know greater than that. So when we do that, we're going to get 6.9 minus 5.1 divided by 0.9 equals a value of 2. We already looked up the value 2 earlier in number 7. We know that that is 0.9772, and that is everything from that value and to the left, remember. So now we want to know what's the value going greater than that, so we take 1 minus that value, and that equals 0.0228, which is the value for number 11 being greater than 6.9. Alright, I'm going to stop the video there and pick back up on number 12 in the next video. See you all in the next video.